All right, let's do an example using these rules we just learned for our complex number. Okay, so the first thing we need to do before we find z times w, or before we find w to the fifth power, or before we do z divided by w, is right now these are in rectangular form. And we're going to go ahead and change them to polar forms, and then we will actually do the problems. That's why I have this space with it listed twice, because we're going to find the polar forms first and then find the results. Okay, so for z, we have the real part is 2 square root 3, the imaginary part is 2, the magnitude of z, or we could call it r, whichever, is the square root of 2 square root 3 squared plus 2 squared. So that would give us 4 times 3 plus 4. So that's 12 plus 4, which is 16, which is 4. Right? Did I do that right? So 4 is the magnitude. So then for theta, we should do a quick sketch. It's a positive positive, so it's quadrant 1. That's easy. So inverse tangent of 2 over 2 square root 3 simplifies to 1 over square root of 3. So that's a pi 6, right? And that is quadrant 1, so that is the correct angle. So that polar form, should we do these in angles or in radians or degrees? Do you care? We did the other little examples in degrees, so should we keep these in radians just so that we have experience with both? Well, in some ways they are. Okay. All right, so we have 4 cosine I sine of pi 6. That's our polar form for z. All right, now let's do w. I'm going to shrink this down a little bit so it's taking up less space. All right, w. So the magnitude of w is the square root of -1 squared plus square root of 3 squared. So that would be 1 plus 3, which is 4. So the magnitude is 2. Wait, did I do something wrong? Okay, and then our argument theta would be the inverse tangent of square root of 3 over -1. Let's figure out the quadrant really fast. So negative positive, so that's a quadrant 2. So that means that for tangent we are going to get quadrant 4 technically, but we need a quadrant 2 angle. So the inverse tangent of negative square root of 3 isn't that like negative pi thirds? Right? Wouldn't this be negative pi thirds? However, we need it to be in quadrant 2. So that would be 2 pi thirds. Adrian, are you checking my work for me? Uh-oh. Somebody else checking my work for me? I forgot to print out my last year notes to make sure I was doing this right. I should probably pull it up if no one's double checking me. All right. Okay. So if these are the correct polar forms for z and w, we can now use the rules we just learned to complete the actual question. I'm going to pause. All right, now that we know the polar forms, let's go ahead and find z times w, w to the fifth, and z divided by w. So z times w would be 4 from this one times 2 from that one, and then that times cosine plus I sine of pi 6 plus 2 pi thirds. So that would be 8 times cosine I sine. Let's get a common denominator here, so that would be 4 pi 6. So pi 6 plus 4 pi 6 would be 5 pi 6. And there's our answer in polar form. What if we want to go ahead and do that in rectangular form? They will tell you if they want it in rectangular or not. But if they don't tell you and you look at the answer key and it's in rectangular, then you know that that's what they wanted and you'll know how to check it. I don't remember. Okay, so cosine of 5 pi 6. Didn't mean to put that there. Plus I sine of 5 pi 6. So that would be 8 times cosine of 5 pi 6 would be negative square root of 3 over 2 plus I times positive 1/2. So that would be 2 goes into 8 4 times, so negative 4 square root 3 plus 4i. So there's the rectangular form, just in case we wanted to take it from rectangular form, solve it, and then put it back in rectangular form. So I don't remember if it asks you to do that or not. All right, let's go ahead and do w to the 5th power. So that would be this. So we go 2 to the 5th power times cosine I sine 5 times 2 pi thirds. Now this is going to be an interesting thing to look at right here. So 2 to the 5th power, first of all, is 2 times 2, which is 4 times 2 is 8 times 2 is 16 times 2 is 32. Cosine I sine, and then that will be 10 pi thirds. Now, how are we supposed to leave our argument? It's not supposed to be, this particular answer is not from negative pi to pi, which is technically what we learned in section 6.3. Our argument is supposed to be from negative pi to pi, and this is not. It's bigger than that. So what are we going to do? So we need to take our 10 pi thirds and find our coterminal angle. So we're going to subtract 2 pi, which would be 6 pi thirds, which would give us 4 pi thirds. That is still over pi, isn't it? So I guess we should go again. Coterminal by subtracting that again, so negative 2 pi thirds. Now that fits in our negative pi to pi for our argument. Okay, so 32 cosine I sine of negative 2 pi thirds. There's our polar form. If we wanted to go ahead and change that to rectangular form, we would just go 32 times the cosine of negative 2 pi thirds. So that's the third quadrant. It would be negative 1/2. And then the sine of negative 2 pi thirds would be negative square root of 3 over 2. And there's an I in there. So that would give us a result of negative 16, 32 divided by negative 1/2, or times negative 1/2. Plus, actually, since it's a negative, I'm not going to do the plus in there. I should have just done, because it's a plus, but it was a negative sign value. So I'm just going to change that to a negative for my rectangular. So 32 divided by 2 is 16. So negative 16 I square root of 3. So there's our rectangular answer. And I'm double checking these with my answers on my notes from last year. They're looking good so far. Okay, that took up a lot of space. Let me size that down for us so that we have room for our last one. Okay, we're doing z divided by w. So z divided by w, that means we're going to take 4 divided by 2, and that's cosine I sine of pi 6 minus 2 pi thirds. So 4 divided by 2 is 2 times cosine plus I sine of, let's change this to 6, so that would be 4 pi 6. So pi 6 minus 4 pi 6 would be negative 3 pi 6. But that simplifies, yeah. So 2 cosine I sine negative pi halves. So there's our polar form, and then if we want to change that to rectangular form, it would be 2 times the cosine of negative pi halves. The cosine, that's 0, isn't it? And then sine of negative pi halves is negative 1. So that would be 2 times 0 plus 2 times negative 1i. So that would result in negative 2i in rectangle.